Hi everybody and welcome. Today's video we're just going to go over some of the basic question types that you're going to see on today's practice questions. So if you happen to get stuck, this will be a pretty good reference to take a look at some of the questions that you're going to see on the worksheet. So the first type of question we'll start off with is something like this. Now this is pretty close to, but not exactly the same numbers that you're going to see on your worksheet for one of the questions. So if you're thinking of what does Mr. Reardon expect to see in terms of showing work and things like that, to be honest, just the basics. So a couple things that are just good practice to do overall. Be mindful of your equal sign. Remember, if you want to move something from the left to the right, you have to show evidence that you've actually moved it. So for example, if we are going to take this -7 term and move it over, we should show that that's what we've done on both sides to prove that. The second thing to note, when I said -7, I meant it. The negative sign that's in front of the 7 is attached to it. So we want to make sure when we're moving something over that we are accounting for its sign. So that's why we're going to add 7 here. All right, so keep on going here. 7 and -7, that simplifies to 0. So we're just left with 3x on the left, and then on the right side, 28 plus 7 gets us to 35. So if we keep going here, we have 3x, or another way to say that would be 3 times x, and the opposite of 3 times x, we can divide both sides by 3. So our final answer here, simplify 3 divided by 3 is just 1, so we're left with a single, or just 1x, and that's equal to 35/3. Now you're welcome to punch that into your calculator. You'll get a repeating decimal, which is okay. I will never care about repeating decimals or fractions or any of those things. However you want to put your final answer is completely fine with me. I really don't like rounding though, so I would prefer that basically if you can avoid it, not to round. So in a situation like this, I'd say 35/3 would be a great way to write your final answer, but I won't take points off either way. All right, a second type of question, and I think probably the most common one that we might get stuck on here would be something along the lines of, let's say, x/5 minus, we'll make this 3/10 is equal to, I don't know, let's say 7/20. So the principles and the setup of all of this is exactly the same, and there's probably like 4 different ways to do this question. But if we're going to follow exactly the way that we did above, we're going to want to use our equal sign and make sure that we're moving things correctly from the left and right. So again, we can view this as -3/10. So we'll follow those same steps. We'll add 3/10 to both sides. And it leaves us in a bit of a predicament here because 7/20 and 3/10, we're trying to add those things together, and that's not going to be the easiest thing for us to do. So we can revert to decimals punched into the calculator. Might see some rounding there, might not. But a good math way to go about this, and some good review for us here, is we want to make sure that if we're ever adding, we need the bottoms to be the same. So we can't add fractions unless the bottom, or the denominator, of all 3 of these things is exactly the same. So if we take a look at what we have 20, and we have 10. Now to make the bottoms the same, as long as we keep balance, so if we do the same thing on the top and the bottom, it's okay. So if we take a look at a number like 20, and take a look at a number like 10, well, 10 goes into 20. So what we could do is, we could multiply 10 by something that gets us a final answer of 20. So 10 times 2 would get us a final answer of 20. So we keep our first fraction, our 7/20. On top, we have 3 times 2, so that'll get us 6. On the bottom, 10 times 2 will get us 20. So we've converted this 3/20 into 3/10 into 6/20. So when we add, always keep the denominator the same, and then we can add the numbers that are on top, or the numerators. So we're left with x/5 and 13/20 on the right side. All of this work on the right was just to show us this final answer gets us 13/20. Okay. So like I said, a bunch of different ways that you can do this. You could multiply by the reciprocal on the left side, so you could view that as 1x/5. You can multiply by 5 over 1. You could cross multiply, which I know is a pretty common way, so you could do 5 times 13 and x times 20. No wrong way to do that, but what I would suggest is, because we're talking about fractions and some of the skills that we're learning in class here, I would strongly push you in the way of multiplying by the reciprocal. So if this is x over 5, the opposite of 1 over 5x would be 5 over 1. And when we do this, what we're going to see is on the left side, it'll be 5x over 5. And on the left side, we'll get 65x, or sorry, just 65 over 20. And 5 divided by 5 simplifies to 1, so we'll just have x. And then on the right side, we'll end up with 65 over 20. Now, like I said before, I don't like rounding, but decimals are totally okay. So if we take a look at this, if we do 65 divided by 20 and we punch that into our calculator, we'll get x equals 3.25. So there's no repeating decimals, it's just 3.25, so an answer of 3.25 is 100% okay here. So as long as you get to this answer of 3.25, I'm happy. Like I said, as long as you're showing your steps, you're okay. I know that there are a lot of different ways that you can go about this question. So hopefully these two question guides help. The first one, kind of more of that level 1 mild level of questions, just showing you what I expect in terms of work shown. The second question here with fractions and adding with different denominators, that's going to be probably the more challenging ones from today's worksheet. All right, as always, thanks for tuning in here, and let us know if you have any questions.